Hello, welcome to UNCG's Sustainability Lecture and Dialogue Series. I'm Sean McInnes, UNC Greensboro Sustainability Specialist, and I'm here to welcome our guest speaker. Dr. Sarah Praskievicz is an assistant professor in the Department of Geography, Environment, and Sustainability, and she is a sustainability faculty fellow. She studies the environmental aspects of river systems, including impacts of climate change on our water resources. And she and her students conduct field-based research to characterize the status of and threats to Greensboro's urban streams and how the condition of those streams can be improved. This year, their research will support stream enhancement projects at sections of the North Buffalo Creek at Revolution Mill and in the East Greensboro neighborhood of Cottage Grove. So just a quick word, if you're watching this video on YouTube, we were a little late to start the recording of the video, but you've only missed one slide. So please forgive us for the little skip in editing. And welcome and please enjoy. Thank you.
Kind of shape and size of the river channel itself, the water quality, and the things that live in the stream. And also, I think there's a kind of a psychological component to urban stream syndrome in addition to these physical changes. So the fundamental change that happens with urbanization is changes in hydrology. So this happens because of changes in the land surface as we move from a rural area to an urban area. So in a rural environment, maybe out of the incoming precipitation, half of it could be infiltrated into the soil, and most of the rest, 40% could be lost to evapotranspiration, which is the combination of evaporation and use of the water by plants, so returning the water to water vapor in the atmosphere. And then that leaves only 10% for the remaining hydrological pathway, which is runoff that contributes to stream flow. What happens when we take this rural area and we build it into a city is, for one thing, we're covering much of the land surface with impervious surfaces like pavement and buildings. So that means there's less opportunity for infiltration because of that impermeability. So maybe now only 15% of the incoming precipitation is infiltrating. And another change is that we're removing a lot of vegetation when we build a city. So what was 40% evapotranspiration now declines to maybe 30%. So because of that reduction in infiltration and evapotranspiration, now there's much more water that is generating runoff. So this is the fundamental change that we see to the hydrology of urban watersheds, is just much greater amounts of overall runoff. And that also relates to changes in the characteristics of that runoff. So we say that urban streams have flashy hydrographs. So a hydrograph is just showing the changes in stream flow over time. And when we compare the hydrograph to a rural stream, which is the green line in the graph, to an urban stream, which is the yellow line, we see this really dramatic shift where the overall peak of the discharge is higher. It's shifted earlier, so the lag time between the peak of the rainfall and the peak of the stream flow is shorter. And then after the recession, after the stream flow returns to normal, after the rainfall event is over, that base flow or low flow in between rainfall events is lower for the urban stream than it is for the rural stream. So there's basically an amplification of the variability of flows in an urban environment with higher high flows and lower low flows. And so that's like a flash flood that you would get in a desert. So very quick to rise and rising to a high peak in response to a rainfall event. And this is again because of the covering of the land surface with impervious surfaces, which reduce the infiltration of the water into the soil. And also the fact that we have these networks of storm drains that are delivering large amounts of water into streams all at once. So accompanying these hydrological changes are changes in the geomorphology of the stream channel. And this happens both intentionally and unintentionally. So as a byproduct of the higher discharge and the flashier discharge, the channel tends to become incised. So stream channels accommodate themselves to the levels of stream flow that they typically have to convey. So if you're increasing the overall runoff, you're going to need a larger channel. So that additional runoff results in erosion of sediment from the stream channel, which typically takes the form of incision. So you get these very deep channels with very steep banks. The banks are unstable and are subject to periodic collapse. And this is problematic because now the stream is not connected to its floodplain. And so when there's water, that water is confined to this narrow and deep channel, which means that the flow velocity increases. So then you get even more incision. So it's this kind of self-reinforcing process. And there's also, like, to deal with these unintentional changes, intentional modifications that are made to stream channels, like channelization, where for one thing, the banks are often lined with a material like concrete or riprap to prevent the banks from eroding and keep the channel in place. And also there's a lot of straightening of the stream channel and removal of debris like logs, because the goal from like a city engineer's perspective is to get the water out of the city as quickly as possible, so that it won't lead to flooding problems. So there's also changes in the water quality from both point sources and non-point sources. So point sources are where there is a specific spot on the landscape, like a pipe that is discharging some sort of pollutant. So for cities, that includes municipal wastewater treatment plants, effluent, as well as industrial discharges. And then there are also non-point sources, which is all of the runoff that is traveling as overland flow through the streets and ends up in streams. So there's many like changes to the water quality that happen as a result of urbanization. Often there's high temperatures because of the lack of riparian vegetation for many urban streams. The fact that it's flowing, the water is flowing over, hot pavement in the summer, and the overall increased flashiness of the hydrograph. And so, with that increased temperature, that can have negative impacts on the dissolved oxygen balance of the water, which is essential for aquatic life. And combined with often inputs of nutrients and organic matter that can also negatively impact the oxygen balance. And then there can be toxic pollutants as well. So urban runoff is generally enriched in heavy metals. Many industrial sources produce complex organic molecules that can have bioaccumulative effects. So there's all sorts of physical and chemical pollutants that negatively impact urban streams. And the end result of all these hydrological, geomorphic, and water quality changes is a reduction in biotic richness. So a regional study from Durham shows that as the watershed imperviousness increases, there are these very predictable decreases in the richness of EPT taxa, which are bugs that live in the stream, the larvae of mayflies, stoneflies, and caddisflies, which are taxa that are highly sensitive to disturbances to habitat or water quality. So often we get a decline in native species and a decrease in the overall biodiversity, and often an increase in invasive non-native species. So those are kind of the widely recognized components of urban stream syndrome. But I think an equally important component is what I call the psychological component, which is just the fact that these streams are either completely ignored and neglected, people don't pay any attention to them at all, or when they do, it's that they perceive them as a nuisance. So, you know, they're full of trash. This photo shows one of the streams that we're working on this semester with my students. There were in this like 200-meter segment of stream, this group that was doing a stream cleanup pulled out 7 shopping carts, which were completely filled with all the trash that you see here. So that, you know, aesthetic component of, you know, these are just like places to dump our waste is really important in how people perceive these streams. And, you know, often this is where homeless encampments end up being established, because it's kind of like the most neglected people in our society end up being forced to occupy the most neglected parts of our urban landscape. And then there are even streams that have just disappeared entirely. So they've been put underground and are now just essentially running through the storm drain system. So, you know, that's kind of the ultimate expression of neglect, is just erasing urban streams from the landscape completely. So we're going to now look at how these components of urban stream syndrome apply to Greensboro streams. So first of all, just to give you the geographic setting of where we are in our watershed, we are in the headwaters of the Cape Fear River Basin, which is the largest river that's entirely within North Carolina. So it discharges into the Atlantic at Wilmington, and it is made up of 2 main tributaries, the Deep River and the Haw River, and we are in the watershed of the Haw River. If we zoom in just to look at the Haw, we see one of its 2 main headwater branches is Reedy Fork, which is the stream that goes through North Greensboro that is impounded to form the watershed lakes that is our city water supply. One of the major tributaries to Reedy Fork is Buffalo Creek, which also has 2 forks. So North Buffalo Creek and South Buffalo Creek. And the boundary between them is pretty much along the railroad tracks. And that's not an accident. They put the railroad tracks on high ground. So that kind of ridge, low ridge that the railroad tracks run along is the drainage divide between North and South Buffalo Creek. So when we look at these urban streams, we see many of the characteristic, you know, symptoms of urban stream syndrome. So these are, you know, USGS gauging stations along North Buffalo Creek, and you can see it has that really flashy hydrograph signature. So every time it rains, there's this really sharp peak in the discharge that then just falls right back down. So that is that characteristic of flashy runoff resulting from the large amounts of impervious surfaces in the watershed. When it comes to water quality, so there are North and South Buffalo Creek are both listed for multiple parameters under Section 303D of the Clean Water Act, which is the part in which states are required to assess the waters within their boundaries to see whether or not they are meeting water quality criteria. And so the listed streams are the stream segments that are failing to meet criteria for 1 or more parameters. And so both North and South Buffalo Creek fail to meet criteria for various numerical standards, including zinc, copper, nitrate, ammonium, and fecal coliform bacteria, and also fail to meet the narrative or qualitative criteria for benthic and fish community diversity. So that's, you know, not unexpected for an urban stream. With the channel morphology, anywhere you go pretty much on these streams, you do see the typical incised channel profile. So very deeply eroded with steep and unstable banks. You know, very low width to depth ratios throughout these streams. These are cross-section diagrams that were produced by the T. Gilbert Pearson Audubon Society way back in 1998, showing various sites on North Buffalo Creek. And you know, the interesting thing is the Audubon Natural Area, which is managed in a more natural state with a mature forest, has a significantly larger width-to-depth ratio, so not quite as incised as these streams that were historically mowed right up to the edge of the channel, some of which still are for flood control purposes. The way in which the riparian vegetation is managed has an impact on the extent to which the channel cross-section has been modified by these increases in runoff. And that Audubon Society report also included examining macroinvertebrates, so the bugs that live in the stream bed. And as you would expect for an urban stream, there are high abundances of basically the taxa that are tolerant of habitat alterations and poor water quality, and a low concentration of taxa that are sensitive. And then on the psychological side, a lot of these streams are, you know, filled with lots of litter. They have these very simplified profiles, so not a lot of diversity in the habitat types within the river channel. So, you know, not that in addition to being ecologically problematic, it's just not very aesthetically pleasing to look at, you know, these kinds of streams. And much of the vegetation that is on the banks is this invasive stuff. So, yeah, there's many streams within Greensboro that have this perception of being a nuisance, of being neglected, and that plays into, there's a sort of like reinforcing dynamic with then, you know, a lack of investment in making the changes that would be needed to support healthier ecosystems in those streams. So as part of my sustainability faculty fellowship, what I've been doing over the past 2 years is establishing a sort of integrated program of research, education, and public outreach around Greensboro's urban streams. So this is primarily done through the class that I teach. So I taught it in fall 2019, and I'm teaching it again this semester, The Water Planet, which is a class that looks at water resources very broadly, both the natural science and the social science side. And the main you know, outcome of this class is that students do a semester-long research project that involves doing physical habitat assessments and water quality monitoring of a site on an urban stream in Greensboro. And the whole goal is that in designing these projects and the sites that the students are working at, I'm, you know, partnering with various community organizations to select sites where the data that the students are collecting actually has some real world application and contributes to improving the health of Greensboro streams and the communities that depend on them. So what we actually do in terms of data collection is the physical habitat assessment uses the protocol developed by the EPA for weightable streams. And this is a pretty intensive, like it takes like pretty much the whole day to do a site where we take a series of measurements both longitudinally along the talveg or the deepest part of the stream, and also a series of cross sections going from bank to bank. And along those profiles, we are measuring various elements of the channel geometry, so the width and depth of the channel. We are noting the channel habitat units, so whether there are pools or riffles present. We're noting the channel substrate, so whether it's fine sediment or gravels or boulders. We're monitoring the density and composition of the riparian vegetation. We're looking for fish cover, so any structural element that can provide habitat for fish in the channel. And we're also looking for direct human modifications like culverts and trash and riprap. So we do this, the students all get the opportunity to go through one of these full physical habitat assessments at one of our sites. And then in addition to that, every week we go out and collect data on water quality at all of our sites. And for this, we use an instrument called an ion selective electrode meter. So it is calibrated to detect the concentrations of particular dissolved ions in the stream. And so what we're measuring this semester, it's a whole bunch of stuff. The water temperature, the conductivity, which tells us the concentration of total dissolved ions, the pH, the ORP, which tells us whether there's oxidizing or reducing conditions, the dissolved oxygen, and then nitrate, ammonium, and chloride, which are all nutrients, and then the turbidity, which we use to estimate the concentration of suspended sediment. So again, the sites that we select are based on what our community partners have identified as being a place where some data collection would be beneficial to some sort of larger project. So I'm going to give just 3 examples of sites that we either are working on currently or have worked on, and how our data is being used. So last year, one of our sites was College Branch, and this is a tributary of North Buffalo Creek that runs just west of downtown. So it has its start along Spring Garden Street near Wafco Mill, and then it flows just east of the Greensboro College campus along the abandoned Norfolk Southern Railroad tracks. And this site is of interest because it is going to be the last segment of the downtown greenway, which is the 4-mile loop that is going around downtown. So the old railroad tracks are in the process of being converted into this last segment of the greenway. And so as a result of that, there's going to be people, walking along this stream, which you can see from the photo. It's a fairly, degraded urban stream at this point. So the idea is, let's make this a more aesthetically pleasing place for people to hang out on the greenway. And, in so doing, we could also maybe provide some ecological enhancements. So the Piedmont Conservation Council, which is one of the groups that I work with, they do ecological restoration projects throughout the Piedmont region, and they were recently awarded funds from the state Clean Water Management Trust Fund to do a stream enhancement project along College Branch. So the data that my students gathered last year is going to be the pre-project baseline assessment of the water quality and physical habitat. And then the hope is, in a future semester, in a couple of years, once this project has been implemented, I'll be able to take another class back there and do, collect the same data to see if there's been an improvement in the physical habitat and water quality as a result of the enhancement project. Another exciting thing is, as with the rest of the Greenway, public art is an important component of the Greenway construction. And for this segment, I was consulted by the artist, Thomas Sayre, who is doing the art installation. And he wanted it to be a stream-themed art project. So I worked with him to select various organisms that live in the stream, like this is a riffle beetle, and he made these beautiful laser cut sheet metal sculptures that are going to be put into paving stones that are in the walkway. So I think this is a good way to address that problem of a stream that is neglected. Right now, like, no one goes to this stream because it's just overgrown and it's, abandoned railroad tracks and it's an eyesore. But, once this project is done, it will be a place where people are jogging and hanging out, and this art will, I think, draw people's attention to the stream, and we'll have like informational displays that talk about the stream. So addressing, not only the physical, benefits that this stream enhancement project will have in terms of the ecosystems, but also the psychological perception of the stream. So turning it into an asset. And then we're hoping to do a similar thing as well on North Buffalo Creek itself, where it flows through Revolution Mill. So this is one of our sites that we're working on this semester. And this is another one where the Piedmont Conservation Council is planning a stream enhancement project. So they're going to be putting in some constructed riffles, which will provide some habitat diversity, and planting some native vegetation along the banks. And this is another, I think, place where there's a real opportunity to increase the visibility and the sort of value that people have for the stream, because it is such a sort of iconic location. The stream actually runs under one of the old mill buildings, which is a really unusual feature. I've never worked on a stream that flows through a building before. And just with all the apartments and restaurants and art galleries at Revolution Mill itself, as well as this is going to be connected to the Greenway system. Once the enhancement project is completed here, this will be, an asset that really makes Revolution Mill more attractive than it is currently. And so just like with College Branch, the data that we're gathering this semester is the pre-project baseline data, and we will do the future post-project monitoring in a future semester. And then one more, which is one that I'm working with the Center for Housing and Community Studies at UNCG, which I saw they just got a major grant from the Robert Wood Johnson Foundation for this project. So they're, they've been working in this community for quite some time, and they asked if, I would consider having my students do some data collection here as well. So of course was happy to do that. So this is the other main site that we're working at this semester. So this is the Bingham Park area in East Greensboro. And Bingham Park itself is built on top of a pre-regulatory landfill for incinerated municipal waste that was in operation between the 20s and the 50s. And this unnamed tributary of South Buffalo Creek, which I've named Bingham Creek, has cut down, it's eroded down into the landfill, and is releasing toxic heavy metals into the stream. So basically, the Center for Housing and Community Studies has been working to get the community involved in this stream, so doing stream cleanups. And they're also doing research on the health effects of people who live in this neighborhood who are potentially exposed to the heavy metal contamination. So this is an environmental justice community. It is a low income neighborhood. It is a predominantly Black neighborhood. And most of the housing that surrounds this stream and the park is public housing. So we are doing our water quality and physical habitat assessments on this stream, as well as another stream in the same neighborhood that doesn't cut through the landfill. So we kind of have a comparison between those two streams. And so, yeah, it's our hope that we can be part of this larger data collection effort so that we can understand the impacts that the residents of this neighborhood have from being exposed to this contamination. So I just want to wrap up by talking about how you can be an advocate for urban streams. So I think the number one way is to join a group. And two that I recommend are the D. Gilbert Pearson Audubon Society, who I've worked with a bit on North Buffalo Creek. They operate the Audubon Natural Area, which is that naturally vegetated area that is immediately upstream from Revolution Mill. And they do events there like nature walks. So it's a great organization to be involved with, especially if you just want to learn more about our local streams and what lives in them. And then another group is the Haw River Assembly, which is our local river keeper organization. And, you know, so we are in the headwaters of the Haw here, and they do various programs, so trips and stream cleanups and that sort of thing. Also through the Haw River Assembly, you can become a River Watch volunteer and do citizen science so that you can collect the kind of data that I've been collecting with my students and contribute to better understanding of what the impacts are on our local streams. And then at a sort of broader level, I think the number one kind of policy thing that can be done to improve urban streams is better land use planning, because all of these impacts that we see on urban streams, whether it's the stream flow, the water quality, and the biological impacts, the root cause of that is the way that we are developing and building our cities. So things like having better stormwater management, having more green spaces, all of this is going to go into addressing the root causes of why these streams are degraded in the first place. And then, yeah, finally, just, you know, love your streams, get to know them, and educate other people about what their potential value is, so that hopefully we can all see these streams as, you know, assets rather than nuisances. And, you know, I'll just close by saying that, like, anything that you do to make streams better, you are making our cities better in doing that. So I just want to acknowledge all of the students from both last year and this year in GES 328. I've now had 37 students contribute to field work for these projects. Also want to acknowledge the Piedmont Conservation Council and the Center for Housing and Community Studies for working with me on these projects. And of course, the UNCG's Sustainability Faculty Fellowship for funding. So with that, I will be happy to take any questions or have any conversations with you all. Thank you so much.
Thank you, Sarah. Really appreciate that informative speech. There's lots of good news and some bad news in there as well. I just want to remind everybody, if you do have a question, you use the raise the hand icon in the participant bar so that we can call on you so we don't talk over each other, and or use the chat box. Any questions? Any comments? You don't have to have a question necessarily. Okay, Robert, you can, and everybody should be able to unmute themselves as well. Robert?
So first of all, I want to appreciate the presentation, just a lot of good information. She mentioned the work of the Audubon Society. And I remember back in the 90s, they did a whole bunch, I think they called it Stream Green. Do you have any history or information on that?
Yeah, I do. Yeah, like there's this whole like sort of saga of what that local Audubon Society chapter has done for North Buffalo Creek. It's a really amazing story. So back in up until the 90s, the city would mow all the vegetation right up to the edge of the stream channel. And so they did this for like flood control purposes. Basically, you know, you just want to get all the debris out of the way so that the flow velocity is greater and it just gets the water out of the city as quickly as possible. But of course, that leads to a lot of degradation of the ecosystem. So really high stream temperatures, really eroded banks. So like that study I was showing with the cross sections, they were comparing, you know, between the streams that had riparian vegetation to those who didn't, and there was hugely significant differences. So they went through this whole process to basically lobby the city to stop mowing up to the edge of the stream channel, and were ultimately successful. But it was a really uphill battle because there was a lot of public concern about it. Yeah, I was talking to people who were involved in this campaign, and they were like, yeah, people were saying, like, if we let the vegetation grow on the stream bank, there will be like snakes there, and there will be people like shooting up drugs. And so like there was like this massive program of education that Audubon Society chapter did, that was, you know, like, no, this is why we need vegetation along our stream channels. And that was ultimately successful. So now like the whole like Lake Daniel Park segment of North Buffalo Creek does have vegetation growing, and that's just been in the last 20 years.
So I'd like to actually mention, I did some work in East Side Park, which is just to the west of the area that you're looking at, Bingham Park.
Mm-hmm.
So that actually runs into Bingham, what you're calling the Bingham screen. In the 90s, as that neighborhood was being revitalized, we actually tried to copy the work that they did at Lake Daniel. So the city wanted to put a pipe in, change it into a storm sewer line. So, but instead of that, we kept the stream, kept the meandering stream, kept the grass from getting cut, and then we laid back the sides. This thing you were saying about you know, not having the vertical sides, and there did have to be this education that you're talking about, because you can imagine low-income neighborhood, everything the same, drugs, snakes, all of that was a concern. That was what, 20 years ago, and it continues to be. Actually, there's a little park that they put right at the other end of the stream from where it goes into Bingham Stream. That might be something useful, because we're on the clean end.
Yeah.
All the toxic stuff that goes into the stream right after you get out of East Side Park. So.
Yeah, that sounds like another great like kind of comparison site to work at. That's good to know about.
Yeah.
Robert, do you want to introduce yourself that's one thing I forgot to mention to everybody, is if you wanted to ask a question, maybe introduce yourself as well before you start.
Okay, so I'm Bob Powell. I teach at A&T. I'm in the architectural engineering program there, and have a long-standing interest in sustainability. I'm a former co-chair of the Community Sustainability Council, and just advocate.
Yeah, good to see you again.
Yeah.
Any other questions? Aaron?
Yeah, thanks, Sarah. That was really cool. I was just curious of, you know, building on what Bob was saying also got me thinking about in the Lake Daniel Park area. I recall there being a student project, maybe it was a master's student at UNCG, who did some kind of before and after work on some of the revitalization that was there. So that's about as far as I can tell you. It's some vague recollection that I have about this, and maybe seeing some of the diagrams or pictures maybe at some point in my time at UNCG, something to maybe dig up, because I found the kind of historical information from the Audubon really interesting, and I'm sure Bob has some other kinds of materials like this to do. Obviously, you're doing baselines to look at what happens after the enhancements, but also having that historical element is really interesting. In kind of thinking about that, I was wondering about two things. Is that it's about the timeline of when the wetlands went in on UNCG's campus, probably before you got here, mm-hmm. and if there's been any kind of impact difference, whatever that, you know, that maybe they're doing that feeds into kind of what you're working on. And if, you know, I love the community partners that you had. I thought it was great, you know, the relationship that you have with them and the kind of before after studies that you could do. But I'm just curious if you've tried reaching out, if there are others that you think kind of should be interested in this, or you know, could be, but you just haven't gotten to, or you've tried and gotten anywhere. I'm just curious about other potential partners who would find this material relevant.
Yeah, I mean, I think one thing I'd really like to do is kind of connect more with the larger regions, since we are in the headwaters. We're, you know, really important for what's going on downstream. So I've, you know, the Haw River Assembly, which I mentioned, like they're a group that I actually was going to do an event with back in March, and then of course couldn't because of the pandemic. But yeah, I think, you know, kind of connecting up with different local groups that are, you know, throughout the entire Haw River or the entire like Cape Fear Basin would be really interesting. So kind of like, you know, share best practices and kind of like standardize some of our data collection so that we can, you know, have broader regional coverage. I think that would be a really good opportunity.
So
I have
wondering,
sorry. I have a question, and my hand was not being seen. Is it okay if I ask?
Sorry, Corey.
It's okay. I was probably on the other page or whatever. This is Corey Johnson from UNCG in Geography, Environment, and Sustainability. Sorry, my camera's not on. I'm having a bad hair day, but I did want to encourage Sarah to incorporate, if you're not already, the qualitative piece into this. You have Bob Powell here, who's a great resource for students to interview. And I was actually, before Bob said anything, I was going to mention that Mike Lewis, who retired here about 5 years ago, and I think you're in his line, basically, Sarah. I think he was pretty instrumental, if I remember correctly, in the riparian vegetation piece of that, like encouraging and providing the science behind how to do that. And I'm sure he would be thrilled if a student reached out to him to interview him about this.
Yeah, that's a great suggestion. Yeah, I do find that whole side of it, the like aesthetics and the communication and the public education and getting people like invested in their urban streams, like I find that really interesting and essential to, you know, this goal of making, you know, more sustainable urban streams.
Sarah, I had a question about the landfill site. I know there's been a lot of news and about some, I think it's a textiles plant or a chemical factory near Greensboro that a few years ago had some runoff issues. They dumped some waste into one of the rivers and it's affecting water quality downstream. And that's been getting a lot of publicity. I'm just wondering if you've had a chance to really measure the amount of, you mentioned heavy metals entering the water stream there, and to what extent the damage is, and just any additional info you can provide on that particular site.
Yeah, so I'm not directly measuring heavy metals. I don't have the analytical equipment to do that. But the nice thing about measuring the turbidity is that gives you a sort of proxy for heavy metals, because many of them bind to suspended sediment grains. So anywhere that you see like an influx of suspended sediment, if it's a contaminated site, then that's where, you know, like the heavy metals are actually making their way into the stream. And yeah, I know the facility you're talking about, they had the 1,4-dioxane release last year, which they basically, what they did is they put it directly into like their wastewater, and it went through the Greensboro wastewater treatment plant, which does not remove, that treatment process does not remove 1,4-dioxane. And so then that dioxane ended up going downstream into the Haw, where it was detected in Pittsburgh's drinking water supply. So yeah, there's a lot of issues with industrial chemicals around Greensboro. There's also the perfluorinated compounds that have been detected in the city water supply, which are believed to have come from flame retardants at the airport. So yeah, that's kind of like what the status of those things are. Just ongoing, you know, revelations about new detections and the regulatory environment not necessarily being able to keep up with a lot of these emerging contaminants.
Thank you.
Yeah.
So we've got a few minutes. If anybody else has any comments or questions.
So I was just wondering, in terms of what you mentioned enlarging your research or community sort of engagement. I wonder if, and then this is, I'm thinking the citizen science that you mentioned with Haw River Assembly, that if that's something that, high school students could do, I think it will be really beneficial for those students too, to be able to be part of, a project like this. And I love what you said towards the end, that the better streams, better city. And so, this interconnectedness of all of us who live in this area, it seems like working on the streams is a great way to do that. And so I don't know, I just wanted to, see if there are ways to do that.
Yeah, that's great. Yeah, so the Haw River Assembly, which does that River Watch training, often they do it for groups, which could be just, like neighborhood groups, or it could be, schools, like school classes. And the North Carolina DEQ also has a program called Stream Watch, where they give teachers resources to do these kinds of assessments with their classes, and then they can upload them to like a kind of Google Map platform. So yeah, there are existing programs to bring kids and adult learners into this process of like citizen science data collection.
Okay, well, going once, twice, 3 times for any comments. All right. Well, I want to thank Dr. Praskievicz, Dr. Kinafuchi for helping organize this, for everybody for coming and participating, for the guests for their comments. Really appreciate that. We will be, next week I will work on the video and providing the video. I started, I think, on your second slide. I forgot to press the button, but we got the vast majority of the presentation. And and as Etsko mentioned earlier, we do have another presentation. Dr. Will Lee will be speaking next Friday at noon. You can register via Eventbrite. He will be speaking about measuring the carbon footprint of urban energy use of urban buildings. And we do plan on having a number of more events this semester and continuing into the spring to highlight the research that both our faculty and students are doing here on campus. You can follow us on social media, Sustainable UNCG. We're on Facebook, Twitter, and Instagram. Visit our website, sustainability.uncg.edu, for more information about all the faculty and other news like the grants from the community housing and or the Center for Community Housing and Development. Got all kinds of information on the website for you. And I just want to say thank you again, and I hope everybody has a great weekend. Take care of yourselves out there.
Bye, thank
Cheers.
you.